In this problem, we're trying to solve a radical equation, and in these types of problems, we have two different radical signs. Before, when we had one radical sign, we'd get the radical sign alone on one side and everything else on the other side, and then we'd square it. If we tried to square this right now, on the left, we've got two terms, so we'd basically have to FOIL this thing, and we would get a pretty complicated result. So that's not going to work. The trick we're going to use here is to put radical signs on both sides of the equation, one on each. Since there aren't any other terms besides these two radical signs, we can do that. All I have to do is add a square root of y plus 7 to both sides. And then I'll rewrite this equation down here. So on the left, we get the square root of 4y plus 13, then our equal sign, and then the square root of y plus 7. Now we can square both sides. Now remember, because we're squaring, we might get an extraneous solution, so a solution that doesn't make sense in the original equation. So we'll have to check whatever we get. But for right now, all this is going to do is get rid of these square root symbols. So we're going to get 4y plus 13 equals y. I wrote a 4 there. It should have been a 7. Y plus 7. And let's see, I can subtract y from both sides to get the variable just on one side. I've got 3y plus 13 equals 7. And then I'll subtract 13 from both sides. And I get 3y equals negative 6. And divide by 3. And I get y equals negative 2. So let's go back and check if we put a negative 2 in here. This would be negative 8 plus 13. That would be the square root of 5 minus, and negative 2 plus 7, that's 5, so square root of 5 equals 0. So we'd get the square root of 5 minus the square root of 5 equals 0. No problems with that. So it looks like y equals negative 2 is a solution to this radical equation.